boxes. Alright, so while you guys finish here, I'm going to start talking. These are the two different theorems about isosceles triangles you need to know. The first, the isosceles triangle theorem, which is the top one, states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if two sides of a triangle are congruent, the angles opposite those sides are congruent. In this picture here, it says that because side AC is congruent to BC, yep, both boxes. So because AC is congruent to BC, we know that angle 1 is congruent to angle 2 because they're opposites from each other. Alright, because that angle right here is opposite from this side, and this angle over there is opposite from that side. So we know that those two are congruent, are opposites. So because the sides are congruent, the angles are also congruent. 611 is the exact opposite. Did you guys notice that as you were writing it? 611 says if the two angles are congruent, then the sides opposite those angles also are congruent. So if the two angles are congruent, the sides opposite those angles are also congruent. Okay? So the top says if the two sides are congruent, the angles opposite those sides are congruent. The bottom says if the two angles are congruent, then the sides opposite. Now when we're talking about the opposite, it's the ones directly across from it. So here's angle 1, that would be the side. Here's angle 2, that's the side opposite. So we know that those two sides are also congruent. Any questions on that theorem, those two theorems right there? So those are called the isosceles triangle theorems. What do we know about an isosceles triangle? Yeah, two or more actually is the correct theorem of it. But yeah, it's two or more equal sides. Mainly we talk about two because if it's more, then we're talking about an equilateral triangle, right? Which is what we're going to get to next. But an isosceles triangle, angles, sides that are opposite are congruent, and so on and so forth. Any questions on those? I got it. You got to copy down to someone else here. Okay. I want those two copied down. Equilateral triangles. Both boxes. Yes, Esme. You win. They rule. Okay, there's this. I'm going to go another minute, okay? Equilateral triangle. Not there yet. One day I'm just going to go right to it.
Wait, what?
Yeah, you can come sit right here. You can see it better. Yeah, you can come sit over there by Case if you want to see it better.
I can see it. Yeah, I still can't.
Get some eyes.
My contacts hurt my eyes.
My contacts suck.
Oh, wait, get up here.
Yeah. Alright, I'm going to move on in about 10 seconds.
Is this the old one? Mm-hmm. Like this is the first one we did?
This is the first one.
Wait, do we have to do another paper separate sheet?
No, you can just do it underneath it. These two relate together. Isosceles and equilateral triangles relate. Alrighty, here you go. Okay, next one are titled Equilateral Triangles. A triangle is equilateral. It's only if it is equal. That's a fun word to say. You know, that's a fun word. Equiangular. Say it, Jason. Equiangular. Equiangular. What do you guys think equiangular means? All equal angles. Oh man, I got judged today. So let's see Trent's new haircut. Very beautiful, very handsome. Is that what that means? Felt right when I released it too, you know. Crock of crap. I wouldn't come up now. I'm really discouraged after the last row. Equiangular. Equiangular.
Are they letting like all age groups go to the city?
I think it's, usually cities is all.
Well, yeah, but like, you know how like the COVID rules, like how last year they
Oh, good. Well, we haven't got cities approved yet.
Well, then
We
why
just set a
are-
date.
Why are they not doing it?
Because
They
they,
got approved. They not approved yet, like they said, don't make any plans.
yeah, don't make like big plans. Like girls, like if you ask a guy,
So we're not supposed to buy hoodies yet?
Well,
Like,
this is the
definitely
thing.
bought hoodies.
No, if you
Oh, it's
buy
okay.
them, you might as like
you
we
can still
could
give
do
it.
something out of school.
Well, yeah, or we were talking about maybe move. This is the tentative date. If it doesn't happen here, we're going to move it to April.
That's fine.
Well, it was in November. That was our first date for it. And then we got next then. But they said wait till the end of February. So that's what we're doing now. And it's just,
So they are planning on that day, but they don't know if it's in their shoot.
it's like a
They all go
50-50
to
shot.
school together, but let's not go over there together.
There's a lot of things that are issues with this whole situation. I don't like a lot of it. I don't understand how we could have a homecoming dance when COVID was like prominent in the school. Like when we had, if you guys remember, when we had the homecoming dance,
We almost had to shut down.
There was
schools,
like-
we had that one.
yeah, there was like a continual like 3 kids a week that were getting it, 4 kids a week.
That's when it hit the worst.
Now we have like 1 kid a week, and we've had like 1 kid in the month of January or something like that. Yeah.
Well, I feel like everyone has to get it eventually.
What a jerk.
Jason.
I'm proud of you. No, I think we've had 2 kids in January get it, or 3 kids. But still, compared to the 15 we had in October and the 23 we had in whatever, November, and
Plus, only like 2 people tested positive when all of our sports people.
just barely we had no kids test positive. And we tested almost like 85 kids or something like that. That's what I kind of wonder too. I kind of think so there's that thing called herd immunity. Herd immunity. I think majority of our kids have had it, and those of you guys that didn't test positive for it probably have had some kind of had it, but never Jason never showed a symptom, right, Jason? So I mean, but you're talking about, I mean, there's probably those kind of issues. What does it feel like not to be able to smell?
I just got a cold, and then I lost my taste and felt like 2 days.
What does it feel like not to be able to smell?
Taste was so bad.
Cause
I
I
lost mine for 2.5 weeks.
I got like the little M&Ms and I was like excited to eat them, but then I
Can't taste anything. And the texture's gross. Like I ate like a soup, like thick noodles, and I wanted it. All drinks taste like water.
There's
Except
no
if you like
condemnation.
I drink pickle juice, and like you can't like you can just taste it in your
salty.
throat, but it's like it's different than like it's
the
burning a little
burning,
bit.
yeah.
But it's
Yeah, it lasts my taste for like a couple days. I lost mine on I tested negative for COVID, so it was like,
So we
Yeah,
got,
mine was
oh,
fine.
I
Yeah,
just
I'm
I'm
still-
still,
I was like,
oh,
okay.
she just got negative, and we're like, bull.
These two
And
suck.
yeah.
my father-in-law got it, and he didn't know he had it, and he said, which is just kind of bad, but kind of funny. So he'd lost his sense of smell. Had no idea he'd lost it, right? Started smelling some real, his wife was in a car with him, and I'm guessing my father-in-law farted, and it stunk real bad. And he couldn't smell it, so he thought it was like a non-stinker. And his wife was like, what the heck is that smell? COVID could be a great thing in that case, man. You could, it's a good, I can't
I would
imagine.
like lose it like very intently, like it would like go away.
That's what somebody said. Somebody says it's like it's comes and goes.
So like it was so weird, and then like I can't smell anymore.
So we'll see, I don't know exactly if we'll have the dance or not. I hope so. I hope for heck that we just do something, because we gotta, I've been really discouraged about the year, not about the virus, but about the year, like being able to go, like have Pat Band do stuff and be able to just do this, any kind of assembly. You know, we've gone an entire year without having one assembly.
Kind of like the first rule though.
Yeah, usually like when I took over student council, my goal was to have 1 or 2 a month. That was my goal, because before that we'd have like 1 every 3 months, and I'm like, man, assemblies are good, because we get out of class, we can learn some stuff, we can have some people come talk to us, whatever it is. And this year, I hate it. I hate not being able to get out and do assemblies.
I don't understand why you can't, like, couldn't we all space out?
No, the auditorium's not big enough. Yeah. Because you get like when you guys took the pre-ACT, we were spaced out what it was, and you fill up the whole bottom, just the sophomores. Like the freshmen are bigger, and they filled up the whole bottom area by themselves. So we could
like
fit.
we're all sitting in a classroom right now, and then we switch classes and we all mix again.
Well, my thing is, when they came out and said the mask to mask, we're okay now. Like when they came out that a month ago, I immediately walked and said, hey, we're doing an assembly. I'll get one scheduled. No assembly.
How about we do like a normal assembly with our masks on, not our wood gets out? Or I mean, no.
No, like
Okay.
a lot of schools have assemblies.
Yeah, it's just based upon the district and the community. If we weren't still in the high category or whatever it is,
We're in the high.
When are we gonna get
It's
out?
the-
Like they said
I don't know.
12 times that they're gonna release it, but
I don't know. I think it's not high anymore. What's it called now?
moderate?
No, they have different levels now. Wasted?
What do you think now have died from it? Like food, and all of them.
So, okay, equilateral. So isosceles, these are almost the same if you guys read it. If a triangle is equilateral, then it is equiangular, meaning if all 3 sides are equal, then all 3 angles are equal. Now this is something very important to pay attention to. Equilateral triangles, what is the measure of all their angles? No, they all add up to be 180, but what is the measure of each one of them? 60. So it only has one option. Equilateral triangles, their angles have to be 60, because all the angles have to be equal. So if all the angles have to be equal, then they only have one option. They all have to be 60 degrees. The bottom box says if all the angles are equal, meaning if all angles are 60, then all the sides have to be equal, right? So in this bottom one, if we know that all the angles are equal and it says the side DE is 7, all these sides would be 7, right? Up here, if it tells us that all the sides are 4, we know it has to be an equilateral triangle, so the angles have to be 60. Any questions on these? Okay, I'm going to go ahead and we're going to do a few examples. I would probably write them down in my journal if I were you guys, just to have them, and then we'll get to our homework. Alrighty?
You were actually really close.
It felt right. Okay, here we go. There we go. Alright, so if I have a triangle like this, and it's blurry still. Wow, that's not even close. If I'm told that this side is 8 and this side's 8, and I'm told that this angle is 30, how could I find that angle up there? Someone raise your hand and tell me how I could find it. Let's talk about, we'll call this A, B, and C. What do we know, Preston? It is an isosceles triangle. So what else do we know because it's an isosceles triangle? Perfect. So that first theorem we talked about. If the two sides are congruent, then the angles opposite those sides are congruent. So if we know this angle right here is 30, then this one has to be 30, which means this angle up here is 120. Now I told you guys something about geometry. Do we trust the picture? No, trust your math.
So that wouldn't be.
No, this isn't, definitely not. As soon as you see that one angle is 30, it can't be an equilateral. Has to. So this is an example of an isosceles triangle. Now, if I'm told this, so let's look at this one. If I'm told here's a triangle and all three sides are congruent, what's the measure of this angle right here? What is it? 60. If all three sides are the same, meaning it's an equilateral triangle, then of course all angles have to be the same, and there's only one option for that, and it's 60 degrees. Okay, any questions so far? So these are the kind of homework problems you're going to see today. X would be 60. Because it's an equilateral triangle, all the angles have to be the same, so all angles have to be 60. Had a brain fart. Okay, here we go. So, if I have another triangle, we'll call this A, B, and C again, and I'm told that those two sides are congruent. What kind of triangle is this? Isosceles. If it doesn't say the third side is, so it's an isosceles. So which two angles are the same? The bottom two. The angles opposite the sides are congruent. Okay, so if I'm told that this angle right here is 2x plus 37, and this angle right here is 3x plus 31, how could I find the measure of all those? Perfect, say it louder. Okay, why? Good. So Maddie just very drilled it. Because this is an isosceles triangle, we can then set these two angles equal to each other, right? So what we can do is we can go 2x plus 37 equals 3x plus 31. Now, solving this, we're going to subtract 2x to both sides. We're going to have 37 equals x plus 31. Subtract 31, so x equals 6. Now we did that, remember, because it's an isosceles triangle and these two sides are equal, then the angles opposite those sides are also equal. So if I get x equals 6, how can I get, yeah, so we just plug it in, right? So we can have 2 times 6 plus 37 and 49. Do I need to plug it into this one? No, because what do we know about these two angles? So if this one's 49, this one's 49. How could we figure out what angle B is if they wanted to know that? Yep, add them together, subtract from 180.
Wait, why don't we just do the thing where you put A and C together and make it equal to 180?
Because we don't know what this angle is up here.
But doesn't it have to equal 180 overall?
It would, but we'd have to know this angle to better do that. And we have no way of finding that angle. Okay? And now if it was an equilateral triangle, then yes, we could add them all up, right? So I'm going to find one of those right now. Here. I think this is actually on your homework. You're going to see this. Let me see here. Here, this one will work. There we go.
On an isosceles, like, you have to split them up like 2x plus 37 equals, that's going to be 2x plus 3x.
So you have to set them equal to each other. You can't go 2x plus 3x because these angles don't add up. We don't even know what they add up to be yet. So, but what we do know about them is that they're equal, so we can set them equal to each other. Now here's one, this is the one I actually see the biggest issue with when it comes to this homework. If we have another isosceles triangle, and this angle right here is 5x plus 12, and I really encourage you to write down this one. Because you will see this today on your homework, and you're going to be like, what in the ever living? Okay. It says it wants us to find the measure of every angle. So it wants, here we're going to, angle A, angle B, sorry, angle C. First, identify what triangle we're dealing with here. What triangle is it? It's an isosceles triangle. These two sides are the sides that are equal. So we know that this angle and this angle are the same. Angle A and angle C are the same, correct? All right. How could I solve this with the information they give to me, though? So,
Would you go 180 minus 12 for that x?
you're kind of getting there, but no, that wouldn't give you the right answer. So, if we add these together, that doesn't equal 180. These two angles don't equal 180. These three equal 180.
So you're gonna make them both equal to 180?
Yeah, that's kind of what Maddie said. Not quite. So think about it. Think deep right now. Remember, oftentimes, geometry is funny, right? It gives you a problem, and sometimes we're stuck with just dealing with the information that they give to us. Now, we know something else about this.
So if you do 5x plus 12 and then you do another 5x plus 12.
Yeah, there we go. Everyone hear Maddie out right here. If this angle is 5x plus 12, this angle also can be 5x plus 12. Why? Because they're equal. Now look at this. This goes into the problem like Liv talked about last time. Now we have all three angles. Now we can add them all up. And set them equal to 180. Is that what it is? 14x plus 40 equals 180. Subtract 40. 14x equals 140, or x equals 10. Is that right? Check my math, everyone. Okay, so how do we get each angle? So the top one, when we plug in 10, we get 4 times 10, which is 40, plus 56 degrees. And these ones are 62, and we don't need to plug it in for A and C, just one of them, because they are the same. I need to do one more before we get to our homework. So any questions on that one? Okay, any questions on that one? So you're going to see those. Now look, that is not the kind of problem I wanted. Okay, here we go. This is the last kind you're going to see today. And first, I'll get it there. I got to get to it. I got to make it first. So it's going to be a triangle that looks like this. And what it's going to say is this is equal to that is equal to that. Now, everyone wait just a second, because I see this happen a lot to people. This is the information they give to us. They say they want to know what x equals. Okay, before we can do this problem, I got to tell you, here we have two different isosceles triangles. We know that the sides are the same, but the angles opposite those sides are not. Right? Because if you guys, I'm going to go down here and then I'll come back up. I can draw a triangle that looks like this. And I know that those two are the same. And then I can draw a triangle like this. And these may all be the same length, right? This, and this may all be the same length. But we definitely know that this other side can be different. Okay? Because, I mean, if you look at my hand here, my hand length doesn't change, but that other third side of the triangle down here changes, right? So if you look up here, I see problems like this all the time, and I see people make a massive mistake on it. What I see is, they think, well, here's the side that's equal, so there's an isosceles triangle, so if that angle's 33, this angle has to be 33. Oh shoot, those are also isosceles, so that's 33 and that's 33. No, that's not the case. These are two entirely different triangles with a different measure down here. So, knowing that, we know that these two are 33. They gave us this one inside of the same triangle. They can be the same because that's the theorem. How can I start to find x? Which angle do you guys think would be the next easiest one to find? Other than Preston. Someone raise your hand. Lane, which one did you find? Here, we'll number them, Lane. 1, 2, 3, or x. Which angle do you think would be the next easiest one to find? Lane? 3 would be really hard because we can't find 3 yet. Like I said, it can't be 33. We can't make the assumption. It's like a picture. Look at my hands. Imagine there was a line right here. Does the length of my hand change if I move my hand like this? No. But look at the bottom line as if, imagine a bottom line down there. Does it change?
Yeah.
Yes. So the angle is going to change. So the sides can be the same, but the angles are different. So you look at the triangle separately. So which angle would be the easiest one to find? Angle 1. How would we find it?
66
So 114, is that right? Okay, then how would we find angle 2? Yep, so angle 2 is going to be 66. Now look, these two, now we're done with this triangle. I'm going to ignore it. Goodbye. Now we're just looking at this one. We already know that this angle right here is 66. What's this one? So 132. So this one's 48. So x is going to be 48 degrees. So you have to think about the triangles separately. Even though all the sides are equal, it doesn't mean necessarily that the angles are equal. You have to look at the triangles separately. Here we have two entirely different isosceles triangles, right? Even though all the sides are the same, that doesn't matter. We don't care. What we care about is the math, the angles, right? Okay. Questions for me on that? That's kind of a harder one, but I'm going to give you guys your homework. I'll be around to help you if you have questions. It's going to be not that one. There will be 3 like that one, but all different, of course. But I'm going to give you 9 problems. Hold on. So, this is 35, that's 35. Okay? That's the angle. So this is an angle E is 30. So this is an isosceles triangle, so those are the same. So how would you do it? Yes. 30 is not 180.
So minus 180.
Yeah.
So 150.
And then divided by 2, because those two would have to be the same, right? Isosceles triangles. Okay, so this isn't asking for an angle, that's asking for the side. Well, is this an equal angle to the triangle? So it's equilateral. So what's one of the sides? 6, so all the sides have to be 6. Well, so you know that these two have to add up to be 140. What do you know about these two? Well, what do you know about these two angles right here? Okay, good. So you got it, right? So you said 140 minus, 180 minus 40 is 140. And if these are equal, then what do you do? No, you're getting close, look. So you know these triangles have to add up to be 140. Hey, come here. Okay, what kind of a triangle is this? Well, look at what it gives you. What does it tell you? All the angles are equal. So what kind of a triangle is it? Equal. Yeah. So if one side's 5, what are all the sides? Good. So it says that angle J is 80. What's angle L? Yep. And then what's this one? Yep. Yep. Got it?
Yeah.
You good?
Just show the right angle, bro. I did it for math, angle about people. But it showed right angle.
Oh, I did?
Yeah.
Well, 44.36, so that's only 80.
I know, well, I did it right here.
Don't trust the picture, right?
I know, but it showed like I found the right angle right here. Like I found it right here. It showed right.
Yeah, we don't trust the picture, Kason. Do we? Kason, do we trust the picture? No. Really? Yeah. Okay, what kind of a triangle is it? Yep, so what's the measure of every angle? So, did you go 180 minus that?
Yeah.
And then divided by 2? Well, which, so that was 22, right? So what is it? It is, it was the same. You just subtract 180, you get this one. And then you can subtract that one, and you get this one. And then you go 44 plus 90, you get this one. So subtract that one. A lot of stuff you get the answer, so you got it. What? Like I've said 100 times, it's oftentimes in geometry, you have to find things they never ask you to find in order to get to the answer that you have to get to.
Did it do decimal?
No, you've done something wrong. You guys, I forgot to stop the recording. Son of a crap snake. Hello, mouse. There you are.